بسم الله. Assalamu alaikum wa rahmatullahi wa barakatuh. TIDRA is honored to start a series of technical workshops in recent technologies and ICT in collaboration with OpenUAE. OpenUAE is a joint initiative that has been between TIDRA and the University of Sharjah that is launched in 2016 to unify open source efforts in the UAE. Today's workshop will be the first in the series that will be an introduction to GIS in partnership with OpenUAE. With you is Mohammed Fakri from the Center of Digital Innovation here at TIDRA. Joining us is Fatma Ibrahim from Dubai Municipality and a member of the OpenUAE community. She will be highlighting the geographic information systems as a defining aspect of the science. We will go over the definition, appearance, importance, and crucial components. We will also review the applications of GIS in various fields such as artificial intelligence overlap to produce unique and innovative systems experience at GIS Center in Dubai Municipality, as it's one of the leading authorities in this field here locally. Then Muhammad Al-Haidari will cover the fundamental concepts of working with the ArcGIS software, along with its Python API that will be introduced through a beginner use case project. Without further ado, Fatma, the floor is yours.
Thanks, Muhammad. بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. Before I start, I would like to thank TDRA for giving me this chance, and also University of Sharjah for this collaboration. So my name is Fatma Ibrahim. I'm a GIS Services Officer in GIS Center in Dubai Municipality, and trainer in human and self development. Inshallah, before I start the workshop, let's agree that any question will be shifted to the end of the workshop. And inshallah, in our workshop, we will be talking about two main parts related to GIS. The first part will be the introductory part of GIS, GIS importance, GIS history, GIS benefits and components. And the second part, we will be covering GIS implementation and application in GIS Center. We will, inshallah, talk about many implementations and projects. Before defining GIS Center, defining GIS, I would like to define the GIS in a very simple way by saying GIS is a spatial system that creates, manages, analyzes, and maps all types of data. And before giving you the brief definition, is GIS a science, art, or technology? GIS is the science of collecting, entering, processing, analyzing, displaying, and extracting geographical and descriptive information for specific purposes. And it's important to clarify that there is a difference between descriptive information and geographical information. For the geographical information, we are talking about the spatial information used like satellite imageries, aerial photographies, and maps. And for the descriptive information, attribute table and the names used for the data. So this definition includes the ability of the used system to enter geographical information and descriptive information, process it means revise it from error, store it, retrieve it, and analyze it. For analyzing this data, even spatial or statistical analysis, it depends on the purpose. And finally, display it on a computer screen or on paper in form of maps, reports, and graphs. is GIS important, or why GIS becoming from important fields and science nowadays. As we know, nowadays hundreds of thousands of organizations and virtually every field are using GIS. Why? Because GIS helps in answering many related questions. If we are studying, for example, phenomena, problem, also for decision making. And in fact, GIS is powerful because it helps stakeholders in decision making. So if we are using GIS, the questions we are willing to have answers, like the definition. What is this? The measurements, like distance, angles, directions, areas. Also the location. Where is, for example, we can ask where is Dubai is located. The condition. What are the cities in UAE with a population of more than 300,000? The change also can be studied using GIS. What is the change that has been happened, for example, to city of Abu Dhabi since 1980, and we can simply see or observe the change from watching the historical images in Google Earth, which is available for all. The pattern distribution, for example, what is the relationship between population distribution and areas of water availability? Also, the most appropriate way, it means the suitable road. We can also have the answer using GIS. What is, for example, what is the most appropriate road between city of Al Ain and Samha? And the last thing we can get the answer if we are studying or making scenarios. For example, what happened if the population of city of Dubai increases about 15,000 people? Before talking about GIS history, it's important to mention that the story started by using geography. And this is started, or it was in 1854 by John Snow. John Snow, he was a doctor. The second picture is for John Snow. He was a doctor. He studied the incidence of cholera disease in London at that time. So he drew a primitive manual map, as we can see the first picture. So this map also showing the distribution of people infected with the disease, and he concluded that the cause of outbreak of cholera at that time was the use of contaminated water. After that time, people started to use geography in solving problems, in studying phenomena, decision making, also studying diseases. Then GIS as a system started in 1964 by Robert Tomlinson. The last picture, he's known as GIS father. So he was the first one who created and discovered modern and computerized GIS. Since that time, GIS has gone through many changes and progress to reach this very high and advanced level we can see nowadays. So here we will be talking about GIS benefits for nowadays. It helps in decision making, but here we are talking about GIS benefits as a system. We can simplify the benefits in one sentence. GIS is used to save time, cost, and efforts. So how this benefits are going to be if we are using GIS? In past, when people started to use geography, so they started to draw maps. They need huge labs and huge amount of labors to draw the maps. But if we are using a system nowadays we are reducing the production time and improving the accuracy, because we cannot compare manual maps and manual maps and system maps. And also for the labors, in past maybe we used 5 from the team to draw a map, or their work was just to draw and paint the map. Now we can do this maybe in 15 minutes by using the system, and one employee can do this. So this is directly going to reduce the need of the labor, and the benefits I explained will reduce the cost indirectly. And it's important to know that operating GIS means operating infrastructure projects, so it needs a huge budget to be succeed. And we need to take this also into consideration. So if we are willing, or if we are going to implement GIS, it's important to it's important for each of GIS components to take their right place. And these 5 components are related, and each one is affecting another one. GIS will not be successful if we are missing some of or one of these components, which are data, technology. For the technology, we are talking about the hardware and application software, methods, and finally human capital, people. For the data, as I mentioned before, we are using geographical information, or we are using descriptive information. And the most important part, which are taking the highest level or highest budget from GIS operation, is data. And it's important to mention that nowadays 80% of, or let's say about 80% of decision making is depending on GIS. The second component is technology. For the hardware, there are specific standards and features for the used hardware, and also for application software. It depends about our purpose. If we are using to analyze the vector data, so we will be using ArcGIS group, and example of data like or maps we are willing to produce by this type of applications, cadastral map, ownership map. Why? Because here we need to produce very accurate maps, especially if they are representing the boundaries or lines of an area. Also, if we are using remote sensing production, like satellite imageries or aerial photographies, we will be using AirDAS products or AirDAS programs, which are classified as raster data, and they are depending on the grid and pixels. For the fourth part of GIS components, the methods, we mean here approach. And we are talking about the analysis. Analysis is GIS hard. Let's say analysis is GIS hard, even if spatial or statistical analysis. If we are producing topographic map, we have a specific method: land use maps, ownership map, cadastral map, or whatever. And for the last component, people who are using GIS, or employees who are using GIS or working on GIS systems, they need like continuous training, and they have to be updated with systems and data methods. Why? Because whatever, for example, we provide data, technology, method, everything successful and advanced. If people are not trained well, GIS will not be successful. And it's important to note that whatever we are providing here to serve human. This was the first part of the workshop. I just introduced and talked about GIS. The second part of workshop is about GIS application and the projects in GISC in Dubai municipality as one of the leading authorities in GIS. And in fact, also it's the formal source of geographical information in Dubai. We have many projects and implementation, but we will be highlighting the most prominent. The first project is BIM project. BIM project, Dubai BIM Roadmap Design and Implementation for Building Construction. BIM refers to Building Information Model. So what's BIM? It's a modern method of building design that provides and exchanges the necessary information about the building at all stages of the building's life cycle, starting from design through implementation and ending with operation and maintenance. This way contributes to discovering and solving problems in the design of building in the early stages and before starting implementation, which will save time, efforts, and cost. So the project aim or the project goal is to develop a roadmap for the application of building information modeling in Dubai and to implement the first phase of it, which will include the possibility of performing a partial automated audit for building design in order to speed the permitting process and increase its quality. As we can see here, the project process includes converting BIM data to GIS and GIS data to BIM. The second part of the second project is green areas maps, AI vegetation detection. Here we are talking about extracting the data. One objective of the remote sensing operations is managing, developing, and updating different image classification methods for data extraction, such as vegetation data. Vegetation data, as we can see in the slide, was acquired from visible and infrared satellite imagery with a resolution up to 40 centimeter, and this is done using NDVI classification tool. After that, distributed to different planning and classes represented on the map. Here, the data represented finally in Dubai green areas map, which is showing green areas distribution. Also, in GIS Center, we have Dubai Here system. Dubai Here system is an electronic system that works on a web browser or portable smart devices and includes 2D and 3D maps that contain all assets, landmarks, infrastructure, facilities, buildings, units, services, networks, economic activity information, environmental and health, also population information for Dubai Emirate. The system has been designed so that different topics and maps can be added to it easily and with the control over the power of the users. It means there will be like a different level of access for using the data. So it can be used by various government entities for different purposes. Also, we have from remote sensing implementations, Geodrome Project. The objective of this project is to acquire a drone-borne three-dimensional aerial photography system. The system is used to conduct accurate aerial photography with the aim of creating accurate maps of areas, installations, and projects in Dubai. So this is done in order to immediately and continually update the comprehensive and unified base map of Dubai. As I said, and I mentioned before that GIS Center is the formal center of geographical data in the Emirate. And this production or uses of data produced by Geodrone will be used by various entities for many uses, for example, monitoring and updating ongoing projects and data. Also, it can be used for effective decision making, studying specific areas to reduce traffic, adjusting the streets, knowing the building construction status, making a terrain maps, monitoring the change in the shoreline. It also can be used for capturing the vegetation, as I explained for you, green areas before, setting public safety plans, calculating the volume of waste. And now I will present for you a video produced by drone. So the video was produced by drone for Dubai Frame in Zabil Park, and the last project is Dubai Geopandemic System. As I said before, that GIS is used to solve the problems, also to solve the problems or studying the phenomena. And also GIS Center and Dubai municipality has a role in combating COVID-19 through the Geopandemic system, which is a geospatial system that was developed by GIS Center at Dubai municipality for COVID-19 command center of Dubai. to support the contaminant plan of COVID-19 by providing rich information about COVID-19 cases in Dubai, health, isolation, and quarantine facilities in Dubai, and other supporting facilities, and finally a set of powerful analytical map layers and tools. All those components were aiming to enable the system's user to take an immediate decision as much accurate as possible by presenting aspects of COVID-19 in one place together. So as we can see, the maps we can see the disease spread out by zooming in, and we can see for each area also the details. Here, the geofencing tool, which is used to draw the boundary, and it helps emergency authorities to take an immediate decision regarding isolation and quarantine facilities at that time. So this was my workshop. Thanks again, TDRA. If you have any question, let me know.
Thank you, Fatma, for the introduction to GIS and its several applications in the UAE. Next, Mohammed will cover the practical implementations of ArcGIS and working with ArcGIS software, along with the introduction into Python APIs that will be introduced through a beginner use case. You will learn how to create and set up an ArcGIS Pro project. You will learn how to navigate around and prepare data with ArcGIS software, and other concepts of programming, including writing a Python script that will work with ArcGIS environment. So without further ado, Mohammed, please, the floor is yours.
Thank you, Mohammed.
If you don't mind, if you can just share the PowerPoint.
Absolutely, yes. Should be shared now.
Yes.
Assalamu alaikum, everyone. This is Mohammed Al-Haydari. I'm an OpenUAE research assistant. I work in the hybrid field of GIS and AI. Today I'm going to, after thanking Tidra for hosting us and allowing us this opportunity. So today I'll give a brief introduction into just a simple concept using PowerPoint before I go and demonstrate with the ArcGIS software a basic project which you can follow with me if you have ArcGIS and preferably Visual Studio Code, or you can actually use any IDE or terminal of your choice. So Bismillah, let's begin. So first of all, let's talk about the fundamental concept that makes a GIS system. That is the coordinate system. You might have heard of the Cartesian coordinate system, which is simply an XY plane. We've been taught this since high school years. The 0, point is known as the spatial reference, seen is in green here. And if we are to plot any other point on this plane, in this case, an example of 4, 5, this coordinates is always going to be in reference to this spatial reference point. If we have a spatial reference point and a spatial system within a spatial system, or I should say a coordinate system, then we can say we have a GIS system. GIS systems are actually a necessity in a plethora of industries and applications. One of them the audience might be familiar of is with gaming. In video games, they use the model of a web application. So your PC or your machine is actually only rendering the images locally. There is no transfer of images or frames, I should say, between your client and the gaming server. The things that is being transferred back and forth is the coordinates and other metadata. And then it is up to you within the gaming the game client to plot these coordinates within the game's spatial reference. So the game has a coordinate system that plots, say, your character and other characters in the game in reference to that spatial reference. If we talk about or if we talk about the use case where with the Earth, with the map of our planet, we're usually talking with decimal degrees. There are other formats with which you can represent the coordinate system that we use for in Google Maps and in any other ArcGIS or any other geoprocessing software. The decimal degrees is one of the most common ones. I've actually plotted here the intersection between the 0 longitude and the 0 latitude for planet Earth. You can see somewhere it is in the Atlantic Ocean. I believe this is the South Atlantic Ocean, if I'm not mistaken. I'm going to take a minute here to show you this in Google Maps. If I navigate to Google Maps and I just type in the search, I just type in 0, 0, it will actually take me to the search, to the spatial reference for Google Maps, which is for our planet. I'm just going to zoom out here. And we can see that it is somewhere in the Atlantic Ocean. This is the spatial reference for Google Maps. And in relation to this point, all the other coordinates around the world are plotted. If you're interested to seeing where your particular coordinates are of your house, for example, or any other custom location, just hit on select or click on any point you want. And at the bottom here, you will see the coordinate or the relative coordinates that Google Maps has used to plot this point that you have selected. All right, back to the slides. So we have the coordinate system. We can use many different software to build a GIS system with a map of our choice, using the data that we can collect from different sources and then perform geoanalytics on them, either with a GUI or or by automating them with a script. The open source software or open source popular choice is GeoPandas. GeoPandas is Python-based, and it is open source, so you can use them freely. However, ArcGIS Pro from Esri also is not open source. However, it does offer you a 21-day free trial if you wish to try it. And I presume that you have at least that today, so you can follow along. So let's go ahead into the software. So this is the ArcGIS Pro software. You are greeted with the welcome page. I'm assuming that you have ArcGIS launched and following with me. So I'm going to begin by creating a blank template. You can start without a template if you wish to fully customize it, but I'm just going to start with the blank template of map. I can save it in whatever folder that I want. I'm just going to save it for the desktop for the time being. Actually, I can save it here. Yeah. Okay, I'll give it whatever name. You can name it whatever you want. I'll just keep the default name. And then, of course, create a new project. Click OK. So we talked about the coordinate system and how it is important to understand that you are working with a spatial reference. The reason why that is because your project, whenever you're working with a project, especially if you're working with both a GUI and a script to automate your geoprocessing, you will need to understand that you have to unify your coordinate system. So in ArcGIS Pro, you can go to project up top here, go to options, and then map and scene on the left-hand side. I'm just going to expand spatial reference, and now you can see this is where we select what coordinates system that we have that we want to use for our project. We have to make sure with ArcGIS Pro that we set the same, or that we use the same coordinate system with our software, with our GUI, and with the script when we do like the script. Because if we don't, then one point will be plot on using a different coordinate system when our display is plotting everything with a first or another spatial reference. We will not see the point that we wish to plot initially, because it's been plotted with a different reference. So initially, when you come to this menu here, you will have spatial reference of first operational layer set as default. You ideally want to select the choose spatial reference. Type in here in the search WGS 1984, because this is the name of the coordinate system, or it's actually a class of coordinate system, but we just need to use the base one. So under geographic coordinate system, under world, select the WGS 1984, and then hit OK. So now we have the coordinate system set. We don't have to worry about some points or some polygons not showing up on our workspace. First thing I like to do is up top in the toolbar, I'll go to map and then select base map. I like to change the base map. Now the base map is just does not contain any data. This is just for displaying purposes. So for me, I like to select the dark gray canvas, just because it's easy on the eyes with the darker color tones. So we have here, I have already zoomed into UAE. We're going to work with Dubai today. However, you are free to select any other emirates, any other emirate in the UAE, or actually you can even work with the entirety of the country if you wish. However, if you want to feel safe and you don't want to do any modifications to the code and the layer naming, then you can stick with me with just Dubai. So now we have the project ready. I'm going to go ahead and begin preparing our data. So for that, first thing, there are many ways to get data. You can buy them from different businesses. You can create them yourself if you have the infrastructure to do that, or you can get them from open source sources, which is what we'll be doing today. ArcGIS has an online portal for that. Up top, I'll go to View and then hit on the catalog pane. On the right-hand side, I'll have the catalog pane. I'll click on Portal. And then the last icon here shows the Living Atlas. This is the source of data that ArcGIS offers us with open data that we can use. And this is not comprehensive for all projects, keep in mind. However, it gives us a good starting point. So in here, I'm going to search for, let's see, UAE Emirates boundaries 2020. It's like United Arab Emirates. Okay, so we want to select this one, United Arab Emirates, Emirate boundaries. The other ones are country and region, which we do not need. We need the first one. So in order to add them to my map, what I'm going to do is right-click and add the current map. On the left-hand side, you see my contents pane. If it is not showing to you, you can again go to the View tab up top and click on Contents. Now it's important to distinguish. I'm going to go back on the catalog pane on the right and select Project, expand Databases, and then expand my project.gdb. This is the geodatabase for the project. A geodatabase differentiates itself from other kinds of databases because it is capable of storing shapes and polygons within a coordinate system, along with associated attributes. So I can just right-click here, hit refresh. This is because I have gotten this this data set from the online portal. It's not going to show this here unless I process it or create new features out of it, or I should say new feature classes out of it. Speaking of, on the left-hand side, what I have imported is known as a feature class. ARE_emirate is a feature class. A feature class is a collection of features, and every feature contains the geometry. The geometry basically means the shape of the polygon and the coordinates of that shape. And I can view this by right-clicking on the feature class and going to Attributes table. I'll see on the bottom here this loading my attributes table, and there we go. This is the record, or this is the table that shows all the features in this feature class. The first one shows the ID of the area of it. In this case, this is for Abu Dhabi. And there are many other associated attributes to that feature. So for today, I'm going to process this feature class in order to extract only the Dubai polygon, which is this one right here. You can see the ISO_sub field. This field or this column shows us which country code, or the emirate code, I should say, for the polygon. We are interested in the fifth one, which is Dubai. We want to do some geoprocessing to extract this out. There are many ways to do this. However, what I'm going to do up top, I'll go to View, Geoprocessing. On the right-hand side, we have the geoprocessing pane. This is where, if I click on toolboxes, this is all the geoprocessing tools that I have in ArcGIS. You can search for one, or you can manually browse to the one that you want to use. Everything that you can do in this geoprocessing toolbox, or I should say toolboxes, you can do with Python, with the ArcGIS API, which is called ArcPy. So for now, I'm just going to use the split. It's a very simple geoprocessing tool. I'm going to go to split. You can use, if you have, pardon me. So we're just going to use the split tool. I'm going to click on it, search for split, and then click on it. So now we have the geoprocessing tool. We can begin using it by filling all these input parameters. If you don't know what a tool does, it is very easy. ArcGIS makes it very easy to understand. Just hover over this question mark, and the documentation is very simple and clear. So you can understand what this tool does and what you need in order to use it. So we'll start with the input features. For the input features, I'm going to select the Emirates boundaries. I should mention that this feature class is basically contains all the features, and each feature is a polygon representing the area of each emirate. So that is what these features mean. In the split tool, again, I'm going to select split features. Again, the emirate feature class, and then in the split field, this is where I'm going to select the ISO sub. The split field is basically going to take group, I should say, all the features with the same value, or with the same unique value within the field that you select here, and it's going to create separate feature classes based on that. This is what the split tool does. For us, because we have every feature that has a unique value, we're going to end up with 7 different feature classes, each of which contains the emirate polygon. So I'm just going to select ISO_sub. The target workspace is going to be our geodatabase. I'm going to browse to it and automatically browse to the project that I am currently have open. I just need to double click on my project, .geodatabase or .gdb, and then hit OK. Now the tool is ready to be run. I'm just going to hit run. The split is complete. So what I can do now is, you can see that it's not showing on the left-hand side. Some tools show it, some tools do not. But it's okay. I can go to the catalog pane again, back to my database. This time I can refresh the database by right-clicking on it and clicking refresh. And now we can see we have new feature classes in our geodatabase. I should note that whenever I delete something from the contents pane on the left, I am not deleting it from the project. I have to delete it from the geodatabase directly in order to completely wipe it out from the project. I can demonstrate this by importing first Dubai, simply right-clicking add to current map. You can see in the view pane or the map view that it is shown here. If I go ahead and right-click on the feature class of DU and click remove, and then I refresh my geodatabase again, you'll see that it's still there, even though I removed it from the contents pane. So I'm going to import it again. So now we have the area for Dubai. I'm going to unselect the Emirate feature class because we don't need to view that and work with it anymore. I can just close this again. If I right-click on DU and click on attributes table again, you will see that this is the only feature that is present in this feature class, which is the one we're looking for. Again, if you wish to do this for Sharjah or any other emirate, you would need to select or you would need to import the desired emirate from here. If you want to be safe with the nomenclature and or the and the script, you don't want to modify the script later, then you can keep it, or you can follow me as I am going. Okay. So now we have imported, or now we have the area for Dubai. Let's go ahead and get another data set. This time is going to be the medical facilities. So the goal of this project is to find all the medical facilities available in a selected emirate, and plot a point wherever we want, and then we want to find where is the top X number of facilities that are closest to the point that we selected. That point can be our home, it can be any point that we select. So that's the objective that we're trying to achieve. We got the Dubai polygon so that we can work with only the city of Dubai, or with only the emirate of Dubai and not with any other. I'm going to get in the medical facilities. The source of this medical facilities data is going to come from OpenStreetMaps. So I will search for OSM medical facilities Asia. Okay. I think it requires medical facilities Asia. There we go. So the one we're looking for is OpenStreetMap medical facilities for Asia. You can see there are other OpenStreetMap data for medical facilities and amenities. You can use those if it suits your project. However, for us, Dubai is in Asia, so we want to add this by right-clicking and then add to current map. Okay, so now on the left-hand side, we have the data. What we want to do next is to make sure, in order to display this, I think all you need to do is zoom in, because if you zoom out, there are too many points to be displayed. So if I zoom in a little bit, you can see all the medical facilities are showing up in my map view in Dubai, within Dubai, and outside Dubai. This goes, as the name implies, for the whole of Asia. What we want to do now to make processing faster, we don't want to process all of the facilities in Asia because we're only interested in the city of Dubai. For that, we're going to do a clip. We're going to clip these medical facilities to the area of Dubai. This is why we have the polygon for the Emirate of Dubai. So in order to do that, I'll go up top in the view, again, view my geoprocessing tab, and then I'll search for clip. Now, some geoprocessing tools, they have a pairwise variant of them. What this means is that if you have a GPU which can utilize multiprocessing, then you can use that pairwise version. With the same exact parameters, they have the exact same parameters, the clip and the pairwise clip. However, the pairwise clip will be faster as it uses a GPU. It uses your GPU if you have one. For simplicity's sake, I'm going to go for clip. For the input data set, I'm going to select the medical facilities feature class. You can see that the output feature class is automatically named for me, which is convenient. And then I want to clip to the DU feature class. So the idea here is that I want to take these medical facilities and any medical facilities that are within this polygon, I want to keep. Any of them that are out, I want to eliminate. So I'm going to hit run. On the left-hand side, you can see my output feature class. I'm going to go ahead and unselect the original medical facilities feature class because I don't need to work with that or see it anymore. You can see now in the map view that the medical facilities are indeed clipped to the polygon that we want. The Dubai polygon has done its purpose. We don't need this anymore. So again, I'm going to unselect that. We have all the medical facilities that are only within Dubai. So finally, let's create the point at the map, wherever we want this to be, which would represent our home or any custom point on the map. If you want to be safe with me and continue with the city of Dubai, and you do not live in Dubai, that's okay. You can select any custom point on the map within Dubai. So in order to do that, I'm going to go back to my catalog pane and navigate to my geodatabase. I'm going to right-click on my geodatabase, go to New, and then Feature Class. This time I'm creating data. So the first two of these medical facilities points or facilities that we have obtained from open sources. This time we're going to create our own data. I'm going to go to Feature Class, create new Feature Class. I'm going to give it the name of my home with no spaces and a camel case. This is the name that is used in the script. If you want to name it any other thing, you can do that. However, you will have to modify it in the script. Because whenever you work with code and you want to link that code to this ArcGIS environment, you will have to reference these feature classes by their name. So this is why you can, if you don't want to change anything in the code later, you can stick to the my home name. Feature class type, I'll select a point because we don't want a polygon. I'm going to unselect the Z values because we're not dealing with 3D right now. And then I'm going to hit finish. There's no need to go through the next pages. We can leave those as the default values and then click on finish. Okay, so now we have the my home feature class on the left-hand side. If I right-click, go to the attributes table, you'll find that it's empty because I just created. In order to plot a point, let's say I want to plot my point here in the middle, and then I don't know. You can see that visually, it's not easy to tell where the closest, let's say, or the closest 5 medical facilities are to, let's say, this point here. Right. So what I can do is go to edit in the edit menu up top, and then click on create. On the right hand side, I have the create features pane. I'm going to select the my home, and now I have all the different tools that I can use to create features within our my home feature class. So I'm just going to work with only a point. So I click on this point option here. And then on the map view, I can zoom in and select wherever I want to place my point. So let's say I'm going to place it light here, let's say. So just by clicking on it, I now have inserted a point in the feature class. All I have to do to finalize the feature class is click on the tick finish button on the bottom. All I can do is hit F2 on my keyboard. It does the same thing. Okay. It says create features completed. I can close out of this. So now if I go to the attributes table of my home, you will find that I have a point. There is no associated attributes, associated with the feature because I only created a point. Now it only has a geometry. The shape here corresponds to the geometry, which we said was just the coordinates, and the shape of the polygon if it is a polygon. Right now it's only the point, so the shape field here only contains the coordinates of the point. Okay. So I believe we have some time so I can show you some cool stuff, which is the symbology. You can see if I expand the My Home feature class, I see a simple point, and on my view pane, I only see a simple point. So what if I can make this a bit fancier? I just need to click on this point here. I get the symbology pane. This is only for, again, this is not, this does not contain any data. This is only for displaying purposes. I believe there is an icon of a home here. There we go. This is a house. So I just need to select it, and we can see that I have an icon of the house. If you have any of the features selected on the map, this is very useful. You can go in the map menu up top, and then you can select clear. This will clear the selection. Do note that whenever you use a geoprocessing tool, you should clear your selection unless you deliberately want to have that selected, because selecting an attribute or a point or a polygon or any feature on the map will limit the scope of the geoprocessing tool to only your selection. So now the data is ready in the ArcGIS environment. We have the points, the points that represent the medical facilities, and we have the point that represents our home. So let's go ahead and go into the code. Before I go into the code, let's talk about what you need to do to link the script or whatever the script, the Python script that uses the ArcGIS API with the ArcGIS environment. In order to link them, you need two things. First, you have to run the script with the ArcGIS Python virtual environment. ArcGIS does come with a virtual environment automatically installed. All you need to do is to navigate to it. So I'm going to go up top, or top left-hand corner to project, and then go to the Python tab. And this will show me the path to my Python virtual environment for ArcGIS. And this is going to have ArcPy already installed. You can see that it is listed here, along with all the other associated packages needed. So now we have this path. I'm going to go ahead and navigate to it because you cannot actually just straight up copy it from here. So I'm going to navigate to this, Windows, users, my user, app data, local. You do need to enable, you do need to view the hidden items. So in your Windows Explorer, just check hidden items so you can see the app data folder. I'm going to go to local programs. It's leading me to ArcGIS after, and then Pro, and then Bing, and Python, ends, finally the ArcGIS Pro Python 3 folder. So this is the folder where the virtual environment is stored. This is where we're going to grab our python.exe file. We're going to use this to execute our code. So in order to work with this, I'm just going to save this path here. You can save it on a notepad for convenience. I'm going to just copy this path, save it here, and then I'm going to extend it by typing /python.exe. I'm going to enclose this with double quotes so that I can later easily use this to execute our script. So now I have the the executing Python virtual environment. Next, we need to get the actual script. So I'm going to paste here the link to the GitHub repo where you can obtain the script. So this is the link. Please navigate to it. I don't believe I'm allowed to comment publicly here. So you will have to type this in. So I'll give you a second here to catch up if you are late behind, and to copy this URL. Okay, so once you've navigated to it, you would have this repo. You can use the workshop manual later. This basically gives you a step-by-step guide to everything that we did today. So if I'm being too fast, or if you did not understand me fully in any of these steps, you can refer to this workshop manual and follow it on your own pace at your own time. The file that we're interested in is the script file, so you can either clone this repo, or you can just download the whole repo as a zip file. Once you download the script, if I go to the directory where I have my ArcGIS project created, I believe I've created it here. No. Here, my project, here it is. So I will need to place the script file adjacent or within my project directory, adjacent to the myproject.gdb. In reality, you can place the script wherever you want. However, because in the script, as I will show shortly, you will find that you will need to reference the geodatabase, and this brings me to the second point that you need to do in order to complete the linkage between your script and the ArcGIS environment. So first thing you need is to execute the script with the ArcGIS Python virtual environment, which is going to be done with this link, with this URL here, or I should say with this path here. And you need to reference the geodatabase because that's how it's going to know where to look for the feature classes that you have named in the script. So I'm going to grab the script and place it here. So this is the script.py file. Before we go ahead and run it, I'd like to give you a brief dive into what's in the code, what each block of code does, and what are the things that you may or may not need to change in order to fit the steps that you have done. Okay, so now you can view the script in any IDE or just with Notepad++ if you'd like. I'm going to use Visual Studio Code. So here is the script that we have. Up top, we have importing of ArcGIS. Don't worry if it tells you that the ArcGIS is not available. This IDE is not configured to the ArcGIS environment. However, we're going to use a terminal or the Visual Studio Code terminal to run it, so don't worry about that. So this block of code here, we have a simple dictionary for all the environment parameters. The first thing is referencing the geodatabase that you have. This is the first thing that you will need to change. So I have named my project. If I go back to my working directory for our project, I've named it my project. I kept the default name. However, here it's going to reference the name of your project, which will automatically name your geodatabase, myproject.gdb. So I'm going to have to change this to my project to match the name of my geodatabase folder. The second thing is as we have discussed, we have the coordinate system. We have to set it to WGS 1984 so that our script remains in sync with the coordinate system that we're using in our ArcGIS environment. We have some global variables here to store our data that we're going to import from the ArcGIS environment. We're going to store them here. This is a setup function that's only going to set up the workspace. It's going to use these dictionary items here to set the workspace path, which is the geodatabase, and the coordinate system, which we've set to WGS 1984. Then we have the read data function. In this read data function, I have the feature classes dictionary. In here, if you have changed the name of the feature classes in your ArcGIS environment, you would need to change the names here. So I'm going to just quickly double check this. I'm going to go back to my ArcGIS, and you can see my home is it has the same name, the feature class as the feature class. This is correct. However, you can notice that I have an additional 1 here. So I will need to change that, as I've left the clip tool with the default auto-generated name here. I'm going to just remove this 1 at the end to match the name as I have it in the ArcGIS environment. This block of code is going to search for this feature class within the geodatabase that we have referenced and import all the features to the global variables that I've mentioned just now, the medical facilities and the my home global variables. Next is going to be the find closest. This is the main function that we're going to do the geoprocessing and automate all the things that we would need to otherwise do in the ArcGIS GUI directly, which is time consuming. So it's going to find the closest X number of medical facilities to our home. You can input whatever number of facilities that you wish. If you want the closest 5 medical facilities, the closest 10, yeah, whenever you call this, as I will show you later, you need to change that number. So in here, this block of code is going to calculate the distance to. This is the main function that is going to use the geometry that we've imported from my home. The distance to is very simple. It's going to take the my home geometry and will calculate its distance or from the my home distance to the medical facilities one by one. So this is a for loop, and it's going to loop through each medical facility and calculate the distance from the home to that medical facility. We will sort the distances before selecting the closest, or before selecting the medical facilities with the shortest distance. Finally, we have the save results. This is not always, you're not always going to save your results back to the ArcGIS environment. In a more production scale project, you would display your results by either sending it through a REST API to a front end, or maybe if you have a native application, you would display it on your own GUI. However, for us, because we're still developing, this is just a beginner project, so I want to visualize my results and see them again on my ArcGIS environment. So I have this function here. It's going to create a new feature class. So again, I'm using the ArcGIS API here to create the feature class, and then use a cursor here to insert all of the output or all of the medical facilities that I found from the previous method, and save it in a new feature class with this method. Finally, we have the main function, or this is where we run all of the aforementioned methods. Over here, you can change the number 5. I have number 5 by default. You can change this to anything you like. If you want to find the closest 10 facilities, you can do that. Just change this to 10. So this is the code and everything that you need to change in it. Let's go ahead and run it and see if it works. So in order to run this, I am in Visual Studio Code. You can use a regular terminal if you'd like. In Visual Studio Code, I hit Control-tilde to bring up the terminal. I will need to navigate to my project directory, where my script is stored. So I'm just going to cd to my project directory. So now I'm in our project directory. You will need to do the same thing if you're on a terminal. You can do that by simply going to your project directory in your Windows Explorer, selecting up top the path, and then typing CMD over it, and then hit enter. You're already automatically navigated with a command prompt or terminal if you're on Linux to this project directory. So I have my script in this directory. I need to run it. Let's do that. So this is where the execution path or Python executable path that we have saved earlier comes into play. So I'm going to simply copy this, paste it into my terminal, and then at the end type the name of the script. If you have changed the name of the script file, you will need to type the respective name. So in this case, I kept it as is, script.py, and hit enter. Okay, which sees we have an error here. Line 1. Okay, I believe maybe, yeah, there we go. So I just needed to remove the double quotes. If you're on a terminal, I believe you will need the double quotes. I'm in Visual Studio Code, so I do not need that. Okay, so I have an error here, non-type. Okay, yeah. So I have a simple fix for the simple fix for this is, or the problem to this is with the name of the my home variable. What I'm going to do is to simply rename this. Actually, should rename this in the geodatabase. I'm going to go to my geodatabase, to my catalog pane, and then I'm going to rename this to, let's say, Muhammad Home. I have experienced this issue before. There's an issue with the name My Home for some reason. It does not like it. Okay, I'm just going to, if you get that error, all you need to do is delete the My Home feature class from the contents pane, and that will unlock your rename ability. That will allow you to rename it, basically. So I've renamed it to Muhammad Home. I'm going to go back to the script, change the name to Muhammad Home, and hopefully it should work this time. Okay, so the environment is set up, the data is reading is complete. This is an output from each method. the closest medical facilities has been found, and the results has been saved in the geodatabase. If I go back to the ArcGIS environment and I refresh my geodatabase, you will see that there is a new feature class called results. This is the output of our script. All I need to do is to right-click again and then add the current map. It may not be visible here. I'm just going to right-click on the dot here. This time I'm not going to click it. As a matter of fact, I can click it. I'm just going to click it to select a larger symbol. I'm just going to select, let's say, circle 3. And then I'm going to change the color of it by right-clicking, and then let's say green, I think would be a good contrast. Okay. Again, I'm going to import the home feature class so I can view that as well. Let me change the symbology again to the house so it's visually more appealing. There it is. Okay. So we can see now that this is my home. The icons in red are the medical facilities, and the icons in green are the selected medical facilities to be the closest to my home. If I go to the attributes table of the results feature class, you will see that I have 5 of them. It may not be clear on the map view because some of them do overlap. If I zoom in, okay, this is by itself. If I zoom into the ones up top, you can see that I have 3 close to each other over here. This is the other one, and the 5th is below it, right over here. So these are the 5 closest feature classes. You can change the number of facilities. I can actually do this, let's say 10. I'm going to rerun the script. Again, it's going to empty the results feature class, and then it will recreate it. If I go back again, I'm going to delete the one that I have in the contents pane. I think this is a good point to mention here, that you can see that on the contents pane, it's not going to update the data that it has or that has updated in the geodatabase. When you use the Python script, you are interacting with the geodatabase and not with the contents pane. The contents pane is specific to just the GUI. So what I'm going to do is delete this results from my contents pane, and then re-import it. I should refresh first and then re-import it back to my workspace so I can view it. Again, I will need to, so not this one, the results feature class, and then I'm going to change the symbology again to make it easier to see. Select green. Now we see that we have 10 feature classes selected instead of 5. If I go to the attributes table to view all the features, we see that we have 10 points. Again, it may not all show discretely on the map view because they overlap. However, if I zoom in, you see that I have 3 grouped here together. The 4th, the 5th here, I believe, yeah. And then I have the 6th here, the 7th, and then the last 3 close to each other in this region over here. You can play around with the script and change it as you like, and then rerun the script in order to get different results. Let's see if I have missed anything. Okay. Yeah, I believe that is going to be it for us. So the workshop manual is on the GitHub repo. You can use it if I've been too fast for you, and work on it at your own pace, at your own time. Yeah, for the ones who still did not get the URL, I will still share it with you. The host can share it with you. There we go. Okay, so with this I can conclude. Thank you very much.
First, I would like to thank you, Mohammed, for the in-depth application and practical implementation of ArcGIS using ArcGIS Pro, of course. And I would like to open the floor for questions. It seems like we have a few coming in. First one is for you, Mohammed. Which format is GIS data in?
I'm not aware. If you go to the let me actually share my screen again. Yeah, it should be shared again. If I go to my project directory and I navigate into the GeoDatabase folder, this is where all the data is stored. You can import data into the ArcGIS Pro environment from a shapefile or a layer file. There are many different formats, different data formats with which you can import into the ArcGIS environment. However, how it is stored, I'm not aware. This is the project file. All you need to do is reference to the parent directory, and that would be enough.
Excellent. One other question coming in. User is asking how they can download OpenGIS data. Is there a link that they can access to download?
There are many different sources for geodata. You can get them from your corporate if you're working in company. If you're looking for open data, you can use the portal and take your time to navigate through the portal. It's in the view. If you go to view, catalog pane, portal, and then the last icon here, this shows you the living atlas. You can download any data here that you can search. Although this database is limited, you can go to open source, OpenStreetMaps, you can go to the website and find data there, or you can go to GeoDubai, which is a government entity under the municipality of Dubai, and you can request data to them, and they actually support, especially if you're a student, they can provide you with data that you need for pretty much any area around the UAE. Or if you have the facility, the infrastructure, like my colleague Fatima introduced the concept of creating geodata with drones. If you have that infrastructure, you can create your own geodata.
Okay. Does GIS take into account weather conditions?
Not that I'm aware of. However, you will need to get your own custom weather data and do your geoprocess or apply that constraint yourself to the limits of my knowledge.
Okay. How is GIS helpful to the average person, you would say?
To the average person, well, I think in this case you can find for this particular project that we presented, you are using your own house to find the closest medical facilities or any other kind of facilities that you might be looking for, perform some geoprocessing on them. Another use case, I believe, for the average person, if you are interested in starting up your own business and you want to find where is the best facility location for your new retail or new business facility, then you can use this to solve what we call the facility location problem and find the best location. Other than that, you can work on research if you are part of a research group to use to perform any kind of geoprocessing really on any kind of geodata for different applications.
Okay. By different applications, do you mean like online retailers? They would use it, and let's say delivery agencies like FedEx and UPS, do they use GIS?
Absolutely. The ArcGIS Pro is fully capable of logistics and solving routing problems. That is part of the toolkit. You can. It has its own set of tools for just routing and logistics problems. So yes, it is definitely capable of it.
Okay. I have a question here for Fatima. User states for her to share the links for the GIS projects in Dubai municipality and how the user can get involved with the GIS Center. Fatima, if you can answer this question.
Hi, Mohammed. Yes, we can share the link.
Okay. Okay.
And it's through Geo Dubai website. I will share the link. They can view all projects and services provided for authorities or individuals.
Okay. No further questions, it seems. So I would like to take this opportunity to thank the trainers today for today's workshop. Thank you, Fatma, and thank you, Mohammed. I would like to also take this opportunity to thank the audience for giving us their time in attending today's workshop, which is the first in a series of workshops with the Open UAE. I would like to also extend my gratitude to TEDRA for giving us this platform to gain knowledge in a magnitude of disciplines, including GIS, and also extend my thanks to the staff in the backstage for making this workshop happen today.